Hi, this is Teacher Abby, and for today's video, we're going to talk about geometric means. In today's lesson, you are expected to attain this objective. Determine geometric means. Before we start with our discussion, we have a simple drill. What is the missing term of this sequence 5, 10, blank, and 40? Timer starts now. Okay, time's up. The answer is 20. For the second item, what are the missing terms for the sequence 2, blank, blank, 54, and 162? Your timer starts now. Okay, so the answer is 6 and 18. For our last number, what is the missing term for the sequence 3/4, 3, blank, and 48? Timer starts now. Okay, time's up. The answer is 12. Did you get the same answers? For the sequence a while ago, how did you get the missing terms? In item number 1, we have the sequence 5, 10, 20, and 40. How did we arrive with 20? We just simply look for the common ratio. Remember, in a previous lesson on geometric sequence, common ratios are the constant factor between consecutive terms of a geometric sequence. We just simply divide each term by the previous term. Like in this example, 10 divided by 5, that will be 2. So the common ratio is 2. And in order for us to get the next term, we're going to multiply the previous term by the common ratio. 10 times 2, that will be 20. In item number 2, we have the sequence 2, 6, 18, 54, and 162. In order for us to arrive with 6 and 18, we just simply get the common ratio. 162 divided by 54 is equal to 3. So the common ratio in this sequence is 3. 2 times 3 is 6. 6 times 3 is 18. For the last item, we have the sequence 3/4, 3, 12, and 48. Again, let us get the common ratio by simply dividing 3 by 3/4. In order for us to divide a fraction, we just simply get the reciprocal of the multiplier. 3 times 4 over 3, that will be 3 times 4, which is 12, divided by 3, which is 4. So the common ratio is 4. So 3 times 4, that is 12. Now, think about this question. What are the three terms between 1 and 16 of a geometric sequence? If you're going to write this one, that will be 1 blank 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 16. Through inspection, the answer will be 2, 4, and 8. 2, 4, and 8 are the terms between 1 and 16. And these numbers are the geometric means, which is the lesson for today. By definition, geometric means are the terms between any two non-consecutive terms of a geometric sequence. And in order for us to get the geometric means, we're going to use this formula. A sub n is equal to a sub 1 multiplied by r raised to n minus 1, wherein a sub n is the last term, a sub 1 is the first term, r is our common ratio, and n is the number of terms. If you're going to remember, this formula is the formula that we use in getting the nth term of the geometric sequence. In this case, we're going to use this one to get the geometric means. Let us try to have an example. For number 1, insert one geometric mean between 3 and 27. If we're going to write this one, we have 3 blank 27. And the missing term is the a sub 2, or the second term. First, we need to find the given. Our a sub n, or the last term, in this geometric sequence is, as you can see, yes, it is 27. How about a sub 1, or the first term? Okay, that is 3. How about our n? N is for the number of terms. Let us count. 1, 2, 3. So the number of terms will be 3. Now, lastly, our r, or the common ratio. Do you have a common ratio? We do not have. Now, using the formula we gave a while ago, a sub n is equal to a sub 1 multiplied by r raised to n minus 1, we're going to find first the r. So let us try to substitute the given. Our a sub n is 27, a sub 1 is 3, then r will be none, then n will be 3 minus 1. If we're going to rewrite that one, that will be like this. We just substitute the given to the formula. In this case, we can simplify 3 minus 1. And we all know that 3 minus 1 will be equal to 2. So, this will be the answer. The next step is we need to divide 3 in both sides for us to isolate r raised to 2. Dividing 3 both sides, that will cancel out 3 and 3 below. And 27 divided by 3, that is 9. And the one that are left behind is r raised to 2. But we are only looking for the value of r. But this is raised to 2. So, as we remember, in order for us to remove the exponent, we just simply place roots. In this case, this is raised to 2, so we're going to put square roots on both sides. Having square root on r raised to 2, meaning we're going to cancel it out, leaving behind r. And the square root of 9 is equal to positive and negative 3. That is the value of r. Since we have two values of r, which is positive and negative 3, let us try first if r is equal to positive 3. Remember, in order for us to get the next term, we're just simply multiplying the previous term by the common ratio. So, we're going to have 3, which is the previous term, multiplying by the common ratio, which is 3. So, 3 times 3, that will be equal to 9. So, the geometric mean of 3 and 27 will be positive 9. Now, let us try to get the geometric mean using the common ratio negative 3. Again, in order for us to get the next term, we simply multiply the common ratio to the previous term. So that will be 3 multiplied by the common ratio negative 3. So that will be 3 times negative 3, which is equal to negative 9. So, the geometric mean between 3 and 27 is negative 9. So, we have either positive 9 or negative 9. For our example number 2, insert 3 geometric means between 5 and 3,125. Let us try to write this one. That will be 5 blank 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 3,125. So, we're looking for a sub 2, a sub 3, and a sub 4. Now, let us look for the given. Our a sub n, or the last term, as we can see, that will be 3,125. Next, a sub 1, or the first term, that will be equal to 5. Next, the value of n, or the number of terms. Let us count 1, 2, 3, 4, 5. So we have the value of 5. And lastly, the value of r, which is missing. And we're going to use the formula given a while ago in order for us to find the common ratio. Let us simply substitute the given on the formula. A sub n, which is 3,125, will be placed here. Then a sub 1, which is 5. R, which is missing, so that will be remain as r. Then the value of n, which is 5, followed by minus 1. It should look like this. Now, let us simplify the exponent. 5 minus 1 is equal to, yes, that is 4. Now, the next thing we need to do is divide both sides by 5, so that r raised to 4 will be remain. Dividing both sides by 5 and cancelling 5 from here to here will remain as r raised to 4, and 3,125 divided by 5 will be equal to 625. And again, we're just looking for the value of r, not r raised to 4. So in order for us to eliminate the exponent 4, we're going to have roots. Since this is 4, we're going to have the fourth root in both sides. Since we have fourth root in both sides, we can able to cancel out the exponent raised to 4, leaving r behind. And 625, the value of its square root of 4, or rather fourth root of 625, will be equal to positive and negative 5. That will be the value of our common ratio, or r. Since we have two values of r, which is positive 5 and negative 5, we have two sequence or two sets of geometric means for 5 and 3,125. Now, let us try first r as positive 5. So, in order for us to get the second term, we just simply multiply the previous term by the common ratio, which is 5. So, 5 times 5, that will be 25. And that will be our a sub 2. In order for us to get a sub 3, we just simply multiply the previous term, which is 25, by the common ratio 5. So, 25 times 5, that will be 125. So, a sub 3 will be 125. For a sub 4, we just simply multiply the previous term 125 by the common ratio 5. That will be 125 times 5, which is equal to 625. So, the a sub 4 is 625. So, the geometric mean for 5 and 3,125, if r is equal to 5, is 25, 125, and 625. So, that is the first set of geometric means between 5 and 3,125. Now, Let us try R having negative 5. Again, in order for us to get the value of a sub 2, we just simply multiply the previous term 5 by the common ratio negative 5. That will be 5 times negative 5 will be equal to negative 25. So our a sub 2 will be negative 25. Now, for a sub 3, simply multiply the common ratio negative 5 to the previous term, which is negative 25. So that will be negative 25 times negative 5. Both negative, that will be positive. So that will be positive 125. So our a sub 3 will be 125. Now, for a sub 4, we simply multiply the previous term 125 by negative 5, which is 125 times negative 5, and that will be equal to negative 625. So the a sub 4 will be negative 625. So that is the another set of geometric means for 5 and 3125 if the common ratio is equal to negative 5. Since we're done with our example, let us have an activity. For number 1, insert 3 geometric means between 3 and 243. For number 2, insert 2 geometric means between 81 and 3. And last number 3, find the 3 geometric means between 2 and 1250. So that will be all. Good luck! That's all for today. If you have questions, you can message me via Facebook Messenger Abby Mendoza. Thank you for watching!